Hi everyone, welcome back to Geeks for Geeks practice and welcome back to another problem of the day. So quickly give me a +1 in the chat if my voice is clearly audible to everyone and everything is working fine so that we can get started. Hi Nav, hi Vanshika and hi Naikaj. So everyone can start giving me a +1 so that we can get started with the live stream as well. And I'll quickly share my screen so that we can start off with the problem. So let's share the screen. Hi Shubham. So I think that my screen is visible now. Hi Shubham. Hi Krishna. Okay. Hi Anil. Okay. So let's quickly start off with the problem for now. Can we start off with the problem? If you haven't liked the video, you can hit the like button and then we'll start off with the problem as well. Okay, so let us start off with the problem. The problem is kind of a puzzle, you can say. So you can write P in the chat for puzzle. It's kind of a puzzle problem only. So the problem says that number of open doors. So what does it mean? So in the end, I think you have to find that what is the number of open doors at the end of a particular procedure. Okay, so if you will see here, it says that you have to consider a long alley. I hope that my voice is clear. Hmm. I think I should change the format as well. Okay. Yeah. So you have to consider a long alley with n doors on one side. Okay. So basically, if it says that, suppose that n value is equal to 10. Okay. Let us suppose that. So in that case, what will happen? We will have the door number one, two, three. Okay. Then we'll have the door number four, five, six, seven, 8, 9, 10. So basically, when n is 10, then there will be 10 doors, you can say. After this particular part, all the doors are closed. So initially, all the doors are closed, right? So you'll say that all the doors initially they are closed, right? So initially, all of the doors that have been given, they are closed. And what you can do is you can move to and fro in the alley, changing the state of the doors as follows. You open a door that is already closed and you close a door that is already open. So if a particular door is open, okay, then you will close it. If a particular door is closed, then you will open it. So it is kind of a flip operation. Please write flip or F in the chat if it is clear. This is kind of a flip operation. Like if a door is open, then in one operation you'll close it. If a door is closed, then you'll open it. It is a flip operation that we will be doing it. Okay, it will be a kind of a flip operation. Now, what you will do here is you start at one end and go on alternating the door state till you reach the other end, then you come back alternating. So it says that in the first go you alter the states 1 2 3 4. So in the first state you can see that you alternate, like you change the state of every door, like from 1 till n you change that state of every door. So you will do it 10 times, right? Like for in the first go, like for first time you will do it for 1 2 3 4 etc. Then in the second time, like you will do it for the door number 2 4 6. Then in the third time you will do for the door number 3 6 9. So basically the multiples of that particular state that you are at. Like for one you will do it for all, then for two you will do for all the multiples of two, then for three you will change it for the multiples of three. Hi Joel. Okay, so all of you can hit the like button, guys, if you have understood the problem till now. Like whatever I've told till now, if it is clear, then you can hit the like button. Okay, so in the first case, what will happen if I have one? So every door will now get opened. Okay, so now if since every door was closed, so now they will get open. So this will be open, this will open. Okay, this will open, this will open, this will open. So all the doors will get open. Okay, in the second go, what will happen now in the second round? All the multiples of 2 like 2 4 6 8 and 10, these doors will now get flipped, they will change. Okay, in the second go. So now with what are these doors? So you can basically say that this door will now become what? This door will now become closed because it will alternate. This will flip and this will become closed. 6 will become closed, 8 will become closed, and 10 will become closed. Okay, they will flip. Right. After, is this much part clear? After this, you will do it for 3 6 9. So now what will happen? Now the door 3, it is open, so it will get closed. Now 6 is closed, so it will get open. 9 is open, so it will get closed. Okay, after that 4 and 8. So because for 4 there is 4 and 8, so what will happen? For 4 I'll get the door as open, and for 8 I'll get the door as open again. Okay, this is what is going to happen. Yeah, hi Chandrasekhar. Looking like seeing you after a very long time. It's very interesting question and kind of a puzzle only. It's great to see you on the practice platform, right? After this, if you'll have 5 comma 10, so you'll mark 5 as closed, and you'll mark 10 as open now. All right. After this particular part, what will happen here is, after you have done it for 5, so then you'll do it for 6. So for 6, there is only one number 6. That is, you'll mark this as closed. Then for 7, you'll mark it as closed here. Then you'll mark it as closed. Then you'll mark 9 as open, and then you will mark 10 as closed. Okay. So this is what you are going to do. Like, first, is everyone clear with this much part? I can see that a lot of people are watching us. So please hit the like button if you haven't, guys. Okay, just quickly hit the like button, and if you have hit the like button, give me a +1. Right, so what we have done here, so in the end it is asking that after following this procedure, like basically for 1 you have to do it from 1 to 10, then for 2 you have to do it for 2 4 2 4 6, and so on and so forth. For 6 you have to do for 6 12, and so on and so forth, right? So in this particular, okay, you are saying that till okay, till 5 only you are clear. So see, for 5 we will do it for 5 and 10. For 6 we will do it for 6 12 and so on, but only 6 door is available na? So that is why we'll alternate that. For 7 we'll do it for 7 14, but only 7 is available, so we'll only switch 7. Then for 8, only 8, like 8 16 is available, but 8 is only there, right? For 9 we have to do it for 9 18, but basically till 9 is only available, right? Then for 10, 10 is only available, 20 is not available, right? So that is why we are doing it like that. Okay, now once we have done this particular part, then what will happen? If you will see, can you count me the number of doors that are open in the end? The number of doors that are open in the end, you will see for this particular case is like, if you will see here, for n is equal to 10, I can say that 3 doors are open. Please write 3 in the chat. I think 3 doors are open. This particular door is open. Like, then the next door that is open is this particular door, right? And the next door that is open is this particular door, correct? These 3 doors are open. Please write 3 in the chat. For n is equal to this, 3 doors are open. Single flip hoga. Yes, after 5 there will be single flip. Okay, so 3 doors are open. Now how can I figure that out, right? So can I say, like, can I say that initially, if you will think that initially a door is closed, okay, so initially a door is closed. Initially, if you will see, right, so a door is closed, right? Initially a door is closed. So if, like, see, if I'm flipping it, right, if I'll flip a door, like if I'll flip a door, okay, even number of times, even number of times, let's say even number of times, let's say 4 times. Okay, so if it is closed, then I'll flip it one time open, then I'll flip it second time closed, then I'll flip it another time open, then I'll flip it another time closed. Okay, so if I will see, if you will see, if I'll flip it for the first time, second time, third time, fourth time, so ultimately I'm getting what? Closed. Okay, is everyone clear with this part? If you see for 2 times, let's say for 2 times, so closed, then I'll open it, then I'll close it. So one time, two time. So for even number of times, I'm getting it as closed, right? If I will flip a particular door even number of times, then it will be closed only, because initially the door is closed. Correct. If the door is flipped even number of times, right, then it will be closed. If the door, if I'll flip it, okay, all of you can hit the like button, guys. I can see a lot of people are watching us. If a door is flipped even number of times, in that case, what will happen? It will remain closed. You can write C in the chat if you are clear with this. Okay. If a door is flipped odd times, okay, this is when even times. If a door is flipped odd times, then what will happen? If a door is flipped odd times, in that particular case, what will happen? See, if a door is initially closed, right, and you flip it 5 times, let's say. Okay, so let's say this is the first time you open it, right? Then second time you close it. Then the third time you open it. Then the fourth time you close it. Then the fifth, then the fifth time you open it, right? So you can see that when it is odd, na, then ultimately it will be open, right? So you can observe one thing, that if it is odd, then it will open. So you can see here that for one, how many devices are there? For one, how many? What is the total number of devices of one? Right? Can I say the total number of factors of one is nothing but one? Right? Total factors. Like if I'll count total factors, right? Total factors of one is one. Total number of factors for four is what? Total number of factors for four is nothing but three factors, right? Three, like four has three factors, that is one, two, and four itself. Correct. What are the total number of factors of this particular number nine? For nine, you have three factors, that is one, three, and nine. Correct. So you can see odd number of factors, right? Odd number of factors. If you will see for 2, so 2 add 1 comma 2, so 2 factors, so that is even, so that will remain closed, 1 and 3. For 3, 1 and 3, two factors. For 5, 1 and 5, two factors. For 6, you can say that 1, 2, 3 and 6, even like even number of factors. So that is why it is not changing now. You can see for even number of factors it will not change, right? Is it clear to everyone, guys? Is it clear that this particular concept is clear to everyone? That when you will have odd number of factors, like you can see for 1, I'm having odd number of factors. Then I'm having for 9, I'm having odd number of factors, and for this 4, I'm having odd number of factors. Please write clear in the chat if everyone is clear with this, and hit the like button, guys. And then we'll proceed further with the next part of it. Okay, so you can see that for n is equal to 10 if you like, if you write any n, let's say if you write n is equal to 20. Okay, so for n is equal to 20, you can understand, like let's say you write any value, right? So what numbers, what type of numbers, okay, what type of numbers have odd factors, have odd number of factors, odd number of factors. The kind of numbers that have odd number of factors is what? The kind of numbers that have odd number of factors is what? Like if you will see for 36, so 36 has one factor, like 1, 2, 3. I think it has 4 as factor as well. Then if you will see, so it has 6, then it has 7, 8, 8, yeah, and then it has 12, and then it has 18, and then it has 36. So you can see here that this particular part, okay, then this particular part, then you can see this particular part, then you can see this particular part, and obviously 6 and 6. So you can see that like it is kind of 1 into 36, right? Then 2 into 18, then you can see that 3 into 12. Okay, then you can see 4 into sorry, 3, yeah, 3 into 12, I think, yeah, 4 into 8, correct. Then 6 into 6 now. So you can see that 1, 2 factors, 2, 4 factors total, then 2 more factors, 6 factors, 7, 8, and 1 more factor, right? So total 9 factors, because this is perfect square. So for perfect square now, please write PS in the chat. For perfect square, for a number which is a perfect square now, there are odd number of factors. Please write PO in the chat or something. Like for a number which is perfect square, it has odd number of factors. Okay, for a number which is a perfect square, it has odd number of factors. You can see that 36 is a perfect square, and it will have odd number of factors because you do 6 into 6 now, because it is a perfect square. So a number will be multiplied twice, like with the same, right? 6 into 6. So that is why it will have an odd number of factors, right? Everyone is clear? That is, this particular part must be clear to everyone, right? Basically, if you'll see for another number, let's say if you see for something like 16, so 16 has factor what 116, right? Then another factor that you can consider is what, 2 and then 8, right? And then if I'll see for another factor, so I can see it as, let's say, 4 and 4 again, right? So basically you can see that what are the total number of distinct factors. Basically this is one factor now, so you can see that one factor, two factor, three factor, because 4 will be considered as the same, then 4 and 5, so 5 factors now. So basically a perfect number has odd number of factors. Is that clear to everyone? 4 into 8 into 4. Okay, okay, sorry, yeah, I did some mistake, I think. 8, oh, okay, 9 fours are. Okay, so I think I have written it wrongly. Yeah, nine fours. Sorry, nine. I should write nine. Sorry, yeah, but that is fine. That is fine. That should not be that like nine fours or 36. Sorry, I should have written nine. Sorry, instead of eight. Okay, so if you will see here, right? So a perfect square has odd number of factors, right? So if I'll say for n is equal to, let's say, 10, so the numbers I was getting was 1, then I was getting for 1 the door was open, for 4 the door was open because it was flipped odd number of times, and then for 9, hi Amit sir, so for 9 also I was getting this thing, that is for 1, 4 and 9, you can observe that I'm getting this particular thing, that is 3 factors, right? So these are all perfect squares, no? These are all perfect squares. If you will see for n is equal to 20, then for 1 I'll flip it odd number of times because it is a perfect square. Then for 4, okay, then because it is a perfect square, then for 9 it will have odd number of factors, so it will be flipped odd number of times, and hence it will be open in the end. And I can say for 16 also. Correct? Is this part clear? Is this part clear? So if you will see, for like, this is a concept that you can understand, that if I'm having the n value, right? If I'm having the n value is 10 here, so I'm having 3 factors, right? So this is nothing but what? This is nothing but observation, and you can say that if n value is 10, in that case you will have under root of 10, that is nothing but 3 point something, 3 point something, that is if you round it to integer, So there are three factors, right? There are three open doors, you can say. If you'll see for n is equal to 20, so 20 under root of 20 is nothing but 4 point something. If you take the integer part, okay, of under root of 20, so that will be nothing but what? 4. Okay, so this is nothing but four factors, because total four factors are like four uh, perfect squares are there. Okay, is that clear to everyone? This part is clear. Observation is clear or not? Okay, is this particular part clear? All of you can hit the like button and give me a plus one if you are clear with this particular approach. Till now, everyone is clear with it. Okay, that if you will consider for any other number, let's say if you consider for n is equal to, let's say, 27, so for that you can see 1 will be there, then 4 will be there, then there will be 9, then there will be 16, then there's going to be 25, right? So you can see that 1 2 3 4 5 5 factors. So under root of 27 taking the integer part will be nothing but 5. So total 5 numbers are there. Basically total 5 numbers are there that will have the door as open, because they will have odd number of factors. All right, great. Now, if I'll ask you, like, what is the time complexity? What is the time complexity? So you will tell me what? You will tell me, okay, that the time complexity is going to be what? Like, if I am doing it, so obviously, if I give you a particular value of n, like let's say n is equal to 30, then you'll say that under root of 25. So you'll tell me that, okay, the time complexity is going to be nothing but order of root n. Correct? This is what you are going to say. You can write yes in the chat. Correct, but if you will see in the expected answer also, na, so this is also given as under root of n, but again this is a mistake, I think, by problem setter, because this is not true. You can further optimize it as well, right? Same thing, but same concept, you can further optimize it. So you see, you can do what? You can do one thing, you can directly apply the square root function or something. But what you can do is now, you can find the under root of n. Like, there's a process using binary search. Okay, what you can do is, using binary search, you can find the under root of n, okay, in logarithmic of n time. Okay, like, because if you will see, you can find under root of n, you can find under root of n in log n time. Okay, instead of doing it in order of square root of n time, you can do it in log n time, because if you'll see, the square root function looks something like this. The square root function looks like this. If you will draw the square root function, so it looks like this. Square root of n looks like this. And if you'll see the log function, so it looks something like this. So this is nothing but logarithmic of n. And log n function, like, basically square root of n, okay, graph is greater than log n. So basically what happens, log is slower, so log is better. So order of log n, you can say, is better complexity. So you can use binary search approach. I can quickly show you this part. Chandrasekhar, you remember this? You can write remember, Chandrasekhar. I hope that you remember this. I have taught you this thing, right? So if you will open, like, find square root of a number, and then you search GFG. Okay, then you'll get through this particular article. Okay, so if you will see, you have to find the square root. So if you will see this particular question also, so you can see this is the question, square root of a number. Okay, so this is the question, right? Yes, that shows the time limit. Yes, obviously. I hope that you remember, Chandrasekhar, we had done this question in the batch. Right. So if you'll see here, now, can you see this? Like, finding the square root of a number, please write log n in the chat. Now you can find it in log n. And you can see the problem setter did not see this thing, and he has written under root of n. But basically, you can find it in log n, na, because you have to find ultimately under square root of n. So you can find it in logarithmic of n time using the binary search approach. And then I'll tell you about the binary search approach as well, like how you can optimize it to log n. Is this part clear till now? Everyone is clear? Please hit the like button, guys, if you haven't. The number of people are more compared to the likes. Okay. Can we proceed further to the to this part? Okay, so for this, now what you will basically do is, you will find, like, you will say that, okay, like, you will find a particular, let's say, value, something like a. Okay, a into a, that is lesser equal to n. Okay, you need to find this thing, because if I'll give you n is equal to, let's say, 30 now, then the answer, like, what is the under root of 30, like 30? Under root of 30 is nothing but what? 5 into 5. Now 5 into 5 is lesser equal to 30, and that will be the answer, because under root of 30 will be what? 5 point something. This will be nothing but 5 point something. 5 point something is what, like it is nothing but 5 only na. So you need to find what, you need to find like greatest, okay, greatest value, okay, greatest value of a, such that, okay, such that a into a is lesser equal to n. I have learned new things. Thank you very much. Yes. So you need to see, if you will observe now, you need to do what? A into A, let's say, is lesser equal to n. So if you will see, if I give you n is equal to 30, then you will tell me that, okay, 5 into 5 is lesser equal to 30. Correct. Because if you will do for 6, then it will be exceeding. So you can obviously see that 5 point something is the answer. So obviously 5, like 5 is the answer, because 1, 4, 9, 16, and 25, these are the answers. So you can observe this particular thing, that 5 into 5 is lesser equal to 30. So obviously 5 is going to be the answer. So you can say that the largest, you can say that largest value of a, right, such that, such that a into a is lesser equal to n. That is what you have to find. Is this part clear? Is this part clear to everyone, that from a range from 1 to n, okay, you have to find a particular value a, okay, you have to find a particular value a, the largest value of a, such that a into a is lesser equal to n. Is that clear? And for that, what you can do is, you can simply do first of all a linear search, that okay, 1 into 1 is lesser equal to n. Let's say n value is 30. So you'll say that okay, 1 into 1 is lesser, then 2 into 2 is lesser equal to 30. Then you'll tell me that okay, 3 into 3 is lesser equal to 30. Then you tell me that okay, 4 into 4 is lesser equal to 30. Right. Then you'll tell me that okay, 5 into 5 is lesser equal to 30. Right. Then after that, 6 into 6 is not. So you'll say that okay, 5 is the answer. Correct? Please write yes in the chat. You will tell me that okay, 5 is the answer, because 1 into 1 is less equal to 30. Let's say n is 30. 2 into 2 is less equal to 30. 3 into 3 is less equal to 30. 4 into 4 is less equal to 30. 5 into 5 is less equal to 30. So you'll tell me that okay, 5 is the answer. Right? Please write 5 in the chat, everyone, and then I'll proceed further. We can apply by search. Yeah, this is what, this is kind of linear search now. From when from 1 to n, you're checking the largest value of a, such that a into a is lesser equal to n. That is nothing but what, that is nothing but kind of a linear search. So you can do what, you can do binary search, right? You can do binary search. Let's say that if you're searching, like let's say if you're searching, and if you want to find for a particular number, let's take one of my numbers only, right? Let's say that if you have n is equal to, let's say, 30, okay, and suppose that you do binary search. So obviously your left limit will be set, right limit will be set. You can set it as 1 to n or something, whatever you require, right? Let's say this is 30 or whatever, I don't care as of now. Let's say you have lnr, and let's say you have a particular mid, okay. Suppose that if your mid into mid, okay, if it is greater than n, if it is greater than n, right? So if mid into mid is greater than n, that means all the people, all the numbers towards the right of mid will also multiply to itself, and it will, like, if mid into mid is greater than n, then mid plus 1 into mid plus 1 is also greater than n. Correct. Mid plus 2 into mid plus 2 is also greater than n. So if mid cannot satisfy, then all the numbers towards the right cannot also satisfy. So I will discard. Now please write D in the chat. I will discard the right half. Guys, I'll discard the right half. We need to check a into a is lesser than we go to the right. Yeah. Okay. So in that case, you will discard this particular thing, right? You will discard this particular thing. So in that case, you will discard the right half. Okay. So in that case, you will search from where, you will say that okay, now my now my right should point to nothing but mid minus 1. Please write m minus 1 in the chat. Mid minus 1 in the chat. The right will now point to mid minus 1, because this will be in your new search space. Because if the mid into mid is greater than n, that then all the numbers towards the right of mid will also be greater than, but you wanted the mid, like you wanted the product of the two numbers to be lesser than. And yes, Chandrasekhar is saying the right thing. You want to find the last this particular thing, the binary search pattern that he has given in the chat. Okay. So if you will observe this particular thing now, if you'll observe this particular thing, then suppose that there is a particular value. Let's say if you have n is equal to 30 here, okay, and suppose somehow your mid is standing here, like suppose that your mid is standing at 3, then in that case 3 into 3, if 3 into 3 is lesser equal to 30 now, so what you will do in that case, you will say that okay, let's say my mid value is 3, then I will store it as the answer. I'll store the current answer, like mid, as the answer, and I'll now search in the right side. I'll search for a higher value now. If this mid into mid, right, if it is lesser equal to 30, then I'll search in the right side. So I'll say that okay, if this was my L, this was my R, so I can just, like, all these numbers will be lesser. I want the highest value of A into A, such that A into A is lesser than equal to n. So I'll search in the right side. So I'll say that okay, n is equal to mid plus 1. Is it clear? For those who are familiar with binary search, they must be pretty much clear with it. Is this part clear? If you are clear with this thing, please make sure to hit the like button, guys. Correct? So let me show you quickly what we can do here. Right. So see, if you have to find for this particular thing, you will say that okay. Let's say int answer. If I have to find, so initially, let's say I'll take it as one or something, and I can have my low value, let's say as one, and high value, let's say as x, and I should take it as long, obviously. Sorry. Right. So long. Okay. This is nothing but finding the square root of n in logarithmic of n time. Right. So this is what binary search. Right. This is nothing but binary search approach. When I do binary search, in that case, the time complexity for finding this thing will be nothing but logarithmic of n. Please write log n in the chat, everyone. Everyone is requested to write log n in the chat if you are clear with this thing. Is everyone clear with this? Everyone is clear with this? You can write login in the chat if you're clear with this thing that basically I'm applying binary search approach here. Okay. So what will I do here? Okay, Rishit is saying clear. Great. So I'll say that while low is less or equal to high, till that point of time I'll be running my binary search. And in this particular case, what will I do? First of all, I'll say that okay, long int is equal to nothing but long int mid value is equal to nothing but low plus high minus low divided by 2. This is the condition for avoiding the overflow. Okay, then if the mid is lesser than equal to the x value, let's say here, so in that particular case x is the basically n here. So if it is lesser equal to x, then we'll say that answer is equal to mid. Okay, we'll store it and then we'll move to the right side. So we'll say that low is equal to mid plus 1. We'll search for a better answer. We'll search for a greater answer because left, all the elements towards the left of mid will be lesser, right? So we need the highest value such that a into a or x into x is like a into a is lesser equal to x, you can say, right? And otherwise, if that is not the case, so we need to search in the left part of the mid. So we'll say that high is equal to mid minus 1, I think, right? This is what we will do, and in the end we can simply return the answer here. Okay, is this part clear to everyone? And this is nothing but binary search, so that will take logarithmic of n time. And let's try and compile it. I hope it will get compiled without any errors. Okay, works on the samples. Let's try and submit it as well to see if it gets accepted. Hey, Yash, what is Chandrasekhar saying? Uh, okay. So did it get accepted? I think it did. Let me submit it again. Right, so you can see that it works for all the test cases, right? You can see that this particular thing works. So is it clear? Everyone is clear with this particular approach and the idea of this question. Now let's quickly copy this here, and we have to find for this particular value of n. So basically this is nothing but you can say n. So let's say I'll mark it as n here. Okay. Again, a similar approach is there. The observation that only perfect square was really nice. Yeah, only perfect squares will have odd numbers, odd number of factors. This is very important. Okay, let's try and see what happens. Works for the samples here as well. Let's try and submit it. I hope that it works if I've not made any mistakes. Okay. Does not work for this kind of a sample. Why is it not working? Did I make some mistake here? For this input, my codes return it's correct. Return is this particular thing. Let's use long. Let me know if I'm making any mistakes here. And hey, Yash, can you take high as n by 2 as square root will surely be lesser than that? Yeah. Okay. So let's take it like that. Will be fine. But let me see this part. High is this, low is this. Okay, answer is equal to this. Now let's try and compile it again. Okay, works for the samples. I think it might not work, but let's see why. So I'm having n, I'm having this particular thing. Okay, let's say that if I want to store it in int, the square root of 1 is 1 itself. Yes, obviously. So let's see what is the answer now. Mm, your code's output is this. Why am I getting this kind of an output? Okay, it is it overflowing? Is it overflowing? It might happen that my mid might overflow, right? Because when I multiply mid to mid, then it might overflow also, right? So yeah, I think what I can do here is that I can check it like this, like if I have this particular thing, right, mid into mid, if it is lesser equal to n, right? So I can check it like mid is lesser equal to n divided by mid. Let's say if I check it like this, so in that case, are you getting this particular point that I am thinking that I might multiply this here? So basically, if mid into mid is lesser equal to n, then I'm thinking that mid is lesser equal to n divided by mid, right? This particular case. So I'm cross multiplying one of the mids here to the right side. So that is nothing but this thing divided by mid. I think now I might reduce the overflow. Take yeah, it this works. Okay, let's see. Yeah, it works, right? So please write clear in the chat, like yeah, it's the same thing, but you can see how I did it. Now I did it in the very first go, like obviously you can see how we observe it. Yes, I meant that we can use n by 2 for high, then for this thing we can 0 will be the answer will be wrong. Okay, but you can see now that initially I have marked the answer as 1. You can mark the answer as 1, or maybe even if you don't mark it, I think that should be fine. But basically, you can observe this particular condition. Is this clear? That you were earlier you were checking for mid into mid, okay, is lesser equal to n. But it, like it might happen that suppose this is in, like if suppose that the mid value is something like let's say long max, okay, and sorry, if the mid value currently is long max, okay, long max, and this particular mid value is long max, if you multiply long maximum to long maximum, okay, if you multiply long max to long max, and this is also long, okay, so this is long, this n value is long, so it will obviously overflow. Now please write overflow in the chat, guys. If this is long, okay, and you multiply two long maximum to long maximum, again learn something new. Yeah, thanks a lot. Right, so if you multiply long max to a long max, that will overflow, guys. Over that will overflow, obviously. Long into long, like maximum values of long multiplied. Let's say if it is, let's say if it is some, let's say that 10 to the power 18 is maximum, suppose, right? So if you multiply 10 to the power 18 10 to the power 18, that will exceed the integer, like long limit, right? So that is why instead of doing that, what you can do is you can simply say that you can have this guy here, right? Take this guy from here and multiply it, cross multiply it there. So that will be nothing but mid is lesser equal to n by mid. It is something like if I'm touching my nose like this, so I can also touch it like this, right? So one and the same thing only. Is that clear to everyone? I hope that everyone is clear with this particular basic thing, right? So basically you can say that in logarithmic of n time, since I'm applying by search, so I'm able to find this particular answer. Is it clear? All of you can give me a plus one if you're clear till this particular point of time. And yeah, we should take care small part. Correct. So if everyone is clear with this question, so you can give me a plus one in the chat, and then I will peacefully end this lecture. So I hope that you have learned a lot and try out these problems. But before ending this session, I will give you the link of my code, which you can go through and submit also if you want. Okay. So just give me a second. I'm just running the algorithm, and then I'll give you the code. Okay, copy code, and I'll paste it in the chat. Right. Okay, so I have pasted this code in the chat, and obviously you can try to submit this problem. And another problem, as I said, this one you can try this one out. This is what you should learn from these problems. Okay, that is the sole reason why we do problem of the day. You can see that you get bonus problems, right? Number of open doors that you are getting. So you did this problem like this. So obviously for that you should be knowing that you can find the square root of a number in logarithmic of n time. Okay, so this was it. All of you can hit the like button quickly, guys. I'm waiting for 1 more minute, and then I'll end the stream as well. And that's what it is for today. So these were the problems. This was the problem that I discussed. It has been asked in TCS, but I think it can be asked in other companies as well. Thanks a lot, Chandrasekhar. But this is something that I should teach in my batch also. Okay. So great. Thanks a lot, Rishit. And all of you can give me a plus one, and then I'll end the stream within a minute. and hit the like button if you haven't. So basically I've solved the problem using square root of n. Naika just saying, but you can do it in logarithmic of n na. So I hope that the problem setter will in future he will improve this complexity, that is logarithmic of n, because you can do it in log n instead of order of root n. We can do this particular question in logarithmic of n. Okay, so with that being said, thanks a lot everyone for joining for today's session, and I hope that you understood the problem overall. Right, thanks a lot, Chandrasekhar. Like, thanks doc, okay. I've learned that problem using but you, as I said, you can do it in log and rhythmic of n time. And Rishit is saying thanks, +1. Okay, and I've shared the link, Abhishek, +1. Okay, so thanks a lot everyone for joining, and I'll see you on Monday. It's good. It's a good solution. Obviously, it is a very good solution, and that is why we insist that you should solve the problem of the days. Because if you'll search for again, if you go to this thing, what is happening? I think my tab has gone to freeze. Okay, yeah. So if you'll search for this thing, let's say GFG POD, but I think again my tab is on freeze. Okay, so I think I should end this stream. That will be better. So thanks a lot everyone for joining. And currently my tag is not working. By Chandrasekhar, thanks a lot. It's like Chandrasekhar was a part of my CP batch. Okay, so thank you everyone for joining, and I'll see you on Monday with another problem of the day. Monday, Wednesday, Friday, I take the problem of the days. Good night, take care. And if you understood this problem, make sure that after the video is over, so after the video goes as saved on YouTube, make sure to comment understood in the chat section if you learned something new, because I told you about the square root of n under root of n approach in logarithmic of n time. Thanks a lot everyone, and good night, take care. Keep on solving the problem of the days, and keep on ordering the t-shirts. Bye, and thanks everyone. Good night.